Okay. Now in IPv4 we have different classes of addresses. These IPv4, these IP addresses actually designed by INA. INA is the international authority who is designing these IP protocol. INA means IANA, International Assigned Numbers Authority. So they did what? They divide this IPv4 into different classes. Now there is 5 classes. Now why they divide them into classes? To fulfill the requirement of different organizations. For example, in a world, maybe some organizations are very big and they may need lots of IP addresses. Then some of the organizations may be not that big, middle-sized organizations. दरवाजा दरवाजा ऐसा कर देना. So some of the organizations may be not that big and maybe not that small. Some middle-sized organizations, they may not need lots of IP addresses for the machines, but they may need lots of IP addresses, not like too much. Then you may have some organizations which is very small and they don't need lots of IP addresses. Small organizations, maybe 200 300 machines they have, and for those devices they need IP addresses. So because divided it into these 5 different classes. Now these 5 different classes are class A, class B, class C, class D and class E. Class A is for the big organizations who's having lots of machines and they need lots of IP addresses, so they can get it in they can get it in class A. Then we have class B. It is for the middle size organization. Then class C is for the small size of organizations. Now class D and E, actually we cannot use it. It is not for the commercial use. Let's see that first. When you see these 3 classes, now these classes, these IP addresses, we have already seen like these IP addresses are 4 parts of 8 bits, like 8 bit, then dot, then 8 bit, then dot, then 8 bit, dot, 8 bit. So it is a 4 parts of 8 bit. So when you see the network, these IP addresses, so they are actually divided into 2 parts. 2 parts, that means one part will be the network part and the other part it is called host part. That means network ID and host ID. Now when you are having 3 machines and their network ID is same, then these machines can communicate to each other. Very simple IP rule. If you have multiple machines and if they have a same network ID, then they can communicate to each other. And if they are having different host ID, that does not matter. They need to be in a same network. For that they need what? Same network ID. Now if they have different network ID, then they cannot communicate. because they will consider as a different network. Now, when you see class A, B, C, D, and E, so these IPs are also divided into this network and host part, network ID and host ID. Now, if you see class A, so the first 8 bits of class A is considered as a network ID. That means it is a network part, and rest of the all bits, that means 8, 8, 8, 24, 3 parts of 8, that means 24 bits, and these bits consider as a host ID and host part. That means if you have multiple machines and they are having same network ID, that means they are in same network. And if they are having a different host, that doesn't matter. Host ID can be any, but network ID is must. Now class B is having 2 parts of 8 bits as a network ID and 2 parts of 8 bits as a host ID. In class C, we have 3 parts of 8 bit as a network ID, and only 1 part of 8 bit is as a host ID. Now class D and class C. Now class D and class E, as I said, they are not for commercial use. So you will not see these as a divided into network and host ID. They are differently multicast addresses and reserved for future use actually. So these are not for us. These are not for commercial use. We can use only class A, B and C addresses. Class D is basically for multicasting, and class E is actually for research and development for the INA purpose, INA engineers. Now let's dig into deep. Now class A, when you talk about class A, so in a class A addressing structure, the first block or the byte, that is the 8 bits, is assigned to the network address, and the remaining 3 blocks are bytes are allocated for the host address, as you can see here. So the class A network and host combination is like this, like first 8 bits are network and rest of the bits are host. So this network dot host dot host dot host. Now class A has first block or byte for a network address, so the total number ID, network ID in form of bits present for class A is network ID is equal to 8 bits. So if you can see, the network ID is what? 8 bits, because only the first part is 8 bits and that part is network part. Now where is for the host ID, there are 3 blocks or bytes, that is what? 3 host IDs, that means 3 part of 8 bits, that means total 24 bits. Now in class A, the first bit of the first block or byte must always be off or 0. So considering the following network address, this. Now what this means is that if you're having all 32 bits, so the first 8 bits, in that first 8 bits, the first bit of that 8 bit must keep it into 0. So here is the x can replace by 0 or 1. So if we replace x with all zeros and then 1 with 1, then we will find the range of class A network address, and that is from 0 to 127. So actually class A range starts from 0 to 127. Now let me, okay, so class A, class A, now it will start from the range will start from, now first when you talk about class, When we talk about the classes means class A, B, C, D and E. So when we talk about the class, so you will talk about only the first part. That means we have these four different parts of IPv4 address. So when we talk about class, then you have to see only the first 8 bit. You will not see other bits, right? Like when anybody says like this is the IP and which class IP is this, then you have to check only the first part. This first part defines class of the IP address. So this first part defines the class of IP address. So for class, first part, first 8 bits define the class. Now when I say first 8 bits, that means you're having all 32 bits like 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So you are having all these 32 bits of IP addresses. Now these bits can be 0 and can be 1. Now for IP address, we talk about, for classes we talk about only this first 8 bits. Now when we talk about class A, so you have to talk about only the first 8 bit, and in that 8 bit class A will start from 0 to 127. Now 0 to 127, when I say, so I'm talking about only this first part. That means here if you see any number 0 or 127, that means it is considered as a class A. That means, for example, your first address will be start from 0 dot 0 dot 0 dot 0. Now here all the parts are 0, all the bits are 0. And it can go up to it can go up to 127. Now 127 dot till what? I will tell you till what. It will go up to 255.255.255. Now why I am saying this? This is your class A range, starting from 0.0.0 to 127.255.255.255. Now why it is 255.255? Because IP will change like this. Like first, it will start from 0.0.0.0, where all your bits are 0. Now your first bit will get enable. That means bit will get enable. Now when this bit will get enable, your number will be what? 0.0.0.1. Then your next bit will get enable. That means this bit, then that bit, then that bit, and then bit. Now when all the bits are enabled one by one, then what value you will get here? You will get 0.0.0.255. That is the total number of all these bits. What is the value of these all bits? Very simple. If you remember, yesterday we have talked about this. It is first bit value is 1, second bit value is 2, third bit value is 4, then 8, then 16, then 32, then 64, then 128. These are the values of your 8 bits. Now when you combine all these values, you will get what? 255. Now when you get 255, that means all your 8 bits are on. Now you don't have any other bit to enable. Now when you don't have any other bit to enable, then what? You cannot get more than 255. You cannot get more than 255 in one part. That means after the 255, then when it reaches to 255 here in the first part, so the next IP will be 0.0.1. This part will get 1 and this part will again get 0. Now why? We can say like it is working like a clock. Like if you have 60 seconds, now you don't have more seconds. If you get 60 seconds, then what happened? The minutes will get 1 and the seconds will start again from 0. Then when it reaches again 60, then the minute will become 2. So actually when this, it will start again from here, like next it will be 1.1, then 1.2, 1.3, 1.4. Now one time comes when it will become 255 again. Now what next? Just like another 60 second. Now this will be 2 and then this will be 255 again. Now like this it will go on, goes on, goes on, goes on, and then what? One time come when what? Your this one will be on 255 and this one will also become 255. That means this is on 60. We can say it is on 59 seconds, 59 minutes, and this one is also become 59. Now what happened? After 69, after 60 minutes, what you will get? 1 hour. So same as here, what it will do? It will change 1 here and then it will become 0, 0 again. And then it will start again from 1.0.1. And then it will goes on to 1.0.1, then 1.0.2, 0, 3, 4, 5. When this will become 255, then this will become 1 again. Then when this will become again 25, this will become 2. Then 255, 2, 255, 3, 255, 4. Now one time comes when this will be on 255 and this will also become 255. Now what next? Remember all parts are having 8 bits. So they cannot go more than 255. Then what happened? Then this will become 2 and these will become 0 again. And then the next IP will start again from 0.2.0.1. That means it will go on to become 2, 3, 4, 5, 6, 255, 1, 255, 2, 255, 3, 255, 4, 5, 6, 7, like this. One time comes when this will be on 255, this will be on 255, and this will be on also 255. Then what? The next will be this will change and this will be 0 again. And then it will start again. And it will start again from 1, 1.0.0.1. And then it will go on to become 2, 3, 4, 255, 1, 255, 2, 255, 3, 255, 4. When all these parts will be 255, then this will become So it will go like this, the IPs will change like this. But and that is why I said here that the IP will go from 0.0.0 to 127.255.255.255. That means 127.255.255.255. This will be the last IP of class A. Why? Because the next what it will be to 128.0.0.0, and this will be in another class. So when this will become 128, that means it will be another class, because our class will start from 0 and it will end on 127. So the last IP for 127, the class A, will be this, because the next IP, very next IP, will be under the class B. Now this is the range of class A, which starts from 0 to 127. But there is a small problem here in class A, and that is what, in class A the number starting from 0. Now remember, in class A the first part is network part and the other parts are host parts. Now if the network part itself is a 0, then the other host part is not valid. That means these IPs which you get here, they will not get valid. So actual range for class A will start from 1. This is what not usable. So actually the range which is 0 is not usable. It is called default range. Because we can't use it, it is reserved. Why we can't use it? Because the first part itself is 0, the network part itself is a 0. So when the network part itself becomes 0, so we cannot use it. So this one we can't use it. Then one more IP we can't use, and that is this is reserved for default range. Now one more range we can't use in class A, that is 127. Now 127 means when the IP starts from 127 of class A. So when you have in the beginning, in the network part, when you have 127, then you cannot use it. It is reserved for loop back. This one is reserved for loop back. Now what is loop back? As the name suggests, loop means looping around. So loop back means the data which we sent on this IP in this network, the data will not go anywhere. It will go and loop back to your own machine. That means it will not go out. It will loop back into your own system. So this range, this IP, this 127 range, the whole range, I'm not saying a single IP. It is a whole range. As you see how the IP change. Now I'm not saying only 0. It is not a one IP, it is actually the whole range. When this change to become 1, when all these numbers will get 255, then only this will be changed to 1, and this will be only changed to 128 when all these zeros will become 255. So all those IPs, all those range, the whole range is what? Reserved. We can't use it. We can't use this range. The whole range is what? Reserved for us, reserved for the purpose. This one is for the default range. This is called default range, and this is what the loop back range. This we cannot use because the first network part is 0. And network part is 0, then we cannot use it. So it is what reserved for default range. Then this 127 also we can't use because it create loop. It create loops in software. That means if you send any data on these range IPs, any IP, that means in host part you can be any. In a host part you can have any number from 0 to 255. You cannot send, you will send the data to that IP, it will get back to your own machine because it will be loop back. This IPs, these ranges are leave, these are reserved for, just we can say it is a testing IP. This loopback is reserved for testing, we can say. Testing, that means some software programmers create some software, some network programs, and they don't have network to test it. So they do what? They use this interface, these IPs, these loopback IPs to test that network programs, that is it working properly or not, is it looping back or not, like it is getting the data or not. So they use this sometime. And for security also sometime people use this, like if they create a system which don't have to connect from outside, they want the connection from only inside the machine, then they will use this range of IP 127. It is also called local host IP, that is only reply from local system, it will not get connected from outside system. So these are reserved. So if these are reserved, then the actual class A range will start from 1 to 126. So actual range starts from 1 to 127, 126 till 126. That means the first IP will be this 1.0.0.0. Now one more thing here in IP addresses. If you are having the host part 0, that means in a host part, remember it's a class A, so this first bit is network part and this bit is host part. So if the host parts all bits are 0, that means that IP you can't use, you cannot use that IP. So if the host part is 0, if the host ID bits are 0, then it is considered as a network address. Network address. Now why I am saying this? Because this network address you cannot use it in any machine. That means if you try to give this IP to any system, that system will not accept this IP. It will not take this IP, it will not work for that IP, it will not work for that machine. So you cannot use this IP, you have to leave this IP. It is called network address, so you cannot use this. So actually usable IP will start from So the real IP will start from 1. It will start from 1, and this will be called valid IP. So it will start from 1 and it is called valid IP, that which you can use. And you know that after 1 dot 1 dot it will come 2, then it will come 1 dot 0 dot 0 dot 3 4 5, and then one time it will become 255. Then the next IP will be 1 dot 0 dot 1 dot 0 again, and it will start again from 1, then 2, then 3, then 4, then 5. Now one time comes when it will become 255, and this will be also on 255. Then what? The next will change 1, and then these will become 0 again, and then the next IP will be 0 dot 1, then 2, then 3, then 4, 255. Then this will be also 255. Then when these two again become 255, then this will change to 2. That means when these two becomes 255, then this will change to 2, and these will remain 0. Then again 255, it will start from 1, then 2, then 5, then 2, 3, 4, 5, 255. Then these two become again 255, then this will be 3. Then again these two become 255, this will be 4. Now one time comes when this will be on 255, and this will be also on 255, this will be also on 255. Then what next? This will become 2, and these will become 0 again. This is how it goes. Now if you see from the network IP and from the first valid IP till this IP, the last IP, you can see all the IPs have same network bit. You can see the network part is same. That means if any machine has this IP, or in between these IPs, any IP of in between these numbers, these IP addresses, they can communicate to each other because their network part is same. Now you see after this IP, the network part is changed. That means from here the next network will start, and this network, the first network, network 1, will end here, and this is the last IP of the network where all bits of host ID are 1. That means on. Now it will call broadcast address. This is broadcast address of this. This is called broadcast IP. And this last IP also you can't use for any machine where all the host bits are 0, all the host bits are on. So you can't use this IP also. That means your valid IPs are in between these broadcast and network IP. You can't use network and you can't use broadcast. So you can use only the IPs in between these broadcast and network IP, and these IPs are called valid IPs. So these IPs will called valid IP, and the rest of the IPs are broadcast IP. A rest of the IPs which you cannot use. So valid IPs which you can use is 255.255.254. So these are valid IPs. Now you can see the valid IPs are starting from here, and it can go till up to 1.255.255.254 because the next IP will be 255, and that will become the broadcast address IP. So when you try to assign any machine this IP, then they will not accept these IPs, one and this one, because this one is a network IP. Now this one you can't use it on normal machine, but we will use it to define the network. That means when you want to say like I'm having a network of 1 class A1, then you can define by this. You don't have to mention all the IPs one by one. You can just mention this IP network address that you are having this network. Then this broadcast IPs are also used to broadcast the network IP. Like if you want to broadcast anything, any message under this network, all the machines under this network, and you want that all these machines should get the IP, the broadcast message. So you can send it on this IP. This is this network's broadcast IP. So it will send the message to only this network. It will not get this message to any other machines of any other network. And after that, the next network will start, and you can see here in this all bits are 0, and this is what network IP of another network. From here the next network is starting. So you can see the next network is starting from here. Now it will go up to what, 127. So it will go up to what, 127, or we can say 126 for the valid IPs. That means 1, then 2, then it will again have that IPs, then it will become 3 here, then it will become 4 here, then it will become 5 here, then it will become 6 here, and then so on. It will reach to 126, that is valid IP, and then it will reach to the end of the IP 127, and that is what, the last IP of class A. Now in class A, how many IPs they are getting? That means in one network of class A, like you are having, this is your one network. That means your IP is, your network is starting from 1.0.0.0 and it is ending on 1.255.255.255.255. Now in between these two IPs, how many IPs you are having? Total IP and the IPs which you can use, like total IP is from network to broadcast, and if you want to see how many you can use, then the first valid IP to last valid IP. So how much you can use is this. So how many IPs are there in this class A1 network if you say, and how many networks we have? This is one network, then second network is starting here, then third network, then fourth network. So how many networks we have? So if you want to see how many networks you have, then you can see that how many network you have. It is from 1 to 126. We can easily guess it is 1 to 126 because the class is defined by the first part, and in class A the network is also first part, and in a first part we have IPs from 1 to 126 or 10 to 127. So total network we have in class A is what, 0 to 127, and that is what, 128. So actually we are having total number of networks in class A is 128. Now how we can guess it, how we can calculate it? Actually, for calculating this we have a formula. So we can say total networks in class A. For that, what you will do here, the formula is simple, raised to 2. Everything will raise to 2 here in digital. So 2 raised to, you will raise 2 network bits. Now 2 raised to network bits. Now how many network bits we have here in class A? So actually we are having so how many networks bits we have actually here? So if you see in class A we have only first part as a network part and the rest of the parts are host parts. So in class A we know that we have first part as a network part and in that first part we have 8 bits. So how many network bits we have? We have 8 bits. So the network bits are 8 bits. Now this is what 8 bit, but there is a twist here. As you see here, what it says here, that this first bit must be 0. This first bit must be 0. It cannot be 1. It cannot be enabled. It cannot be enabled and it must be 0. It is reserved. What it's saying, has the range stand between 0 to 127 for class A, but the complication is that the network address of all zeros, that is 0000, is reserved for default route and the 127 is reserved for loopback address used for diagnostic. Thus, this both numbers cannot be used for specifying class A network address. So henceforth class A range is 1 to 127 as I said. Now what it says here, with the first bit of the first byte reserved, there remains the 7 bits out of 8 for addressing. That means this first bit, it says that it is reserved and it must be 0, it cannot be 1. So that bit is what reserved. So totally we have what, 7 bit for addressing. And that means what, as a result, the total network that can be obtained in class A is what, 128. So why 128? Because we have to leave the first bit. That means what? And why we are leaving that first bit actually? Now why we are leaving that first bit? As I said here, now let's assume this is the first part, then dot, and then you have rest of the parts like 1, 2 and 3. Now when you are having the first part of 32 bits and these are the 8 bits of that first part and these are the values of that first part 8 bit. Now remember, if suppose you enable the first bit and you disable all the other bits like 0 1 2 3 4 5 6 7 8. Now what happen if you enable this first bit in class A? What happened? The value will be what, 128. That means at the beginning you have to type 128 dot. Now when the first part is 128, that means what, it will no longer remain in class A because your class A is ending on 127. So you cannot enable this first bit. See, I have not enabled any other bit, only the first bit I enable and it becomes what, 128 because the first bit value is 128. So if you write 128 here on the in the first part, that means what? It is going into class B. It is getting out of class A because your class A is ending on 127. So it is reserved that your first bit must be 0. So this first bit is reserved. So you cannot enable that bit. Now you can enable all these bits. That means you can enable rest of the bits like 1 2 3 4 5 6 7 8. You can enable all these bits except this first bit. Then if you combine all these values, like you can combine these values 64 32 16 8 4 2 1, and you will get only 127. It will not get more than 127. So you can enable disable any of these bits, but you cannot enable this bit in class A. So you are having what? One reserve bit. Now one reserve bit means you have to minus the reserve bit. That means from network bit you have to divide the reserve bit, and then what you get is your total number of network. So how many reserve bits we have? We have 1. So when I do this, when I remove this, so what I get? I will get 2 raised to 7. And why I am saying this? You see, I will show you in calculator that if you raise 2 to 8, then you will get what? 1256. That means it is saying you are having 256 network, but that is not true. We know that we are having a network of class A. In a class A we are having a network of 0 to 127, and that means we are having 128. Now because if you enable this, if you calculate 2 raised to network bits, then you will get what? 2 raised to 8, and that means what? You get total number of network 256. That is not true. So actually what? We minus the reserve bit from the total bit. So when we minus the reserve bit, so when we deduct the reserve bit, we will remain what? We will remain with 7. So when you do 2 raised to 7, so you will get actually 128, and that is what the real value we are getting of network. So in class A we have what? Total number of networks are 128. This is total number of networks we are having. Now total number of networks like this, like 1, then we have 2, then we have 3, then we have 4 5, and we have till 127 from 0. Only what? We can't use 0 and we can't use 127, so we can say 1 to 126, but we cannot say like the range will start from 0 to 127, but the usable range is what? 1 to 126. So we have total number of networks are 128. Now in 128 networks, how many IPs we are getting in per network? Like host IPs per network. That means we are having what? Total number of networks are total number of networks are 128. And now when you want to calculate in one network, how many IPs you are having. IPs, that means you can assign to a machine. So as you see here, it's too much, it's too many IPs. If you can assume, you see it is starting from the 000 and it is ending on 255, and it is not getting it like that. It is changing it like seconds and minutes and hours. Like first one will get the 1 2 to 255, then the second will become 1, then 2552, 2553, 2554. And just right now we have seen that how much time it will take to reach this 255, 255, 255, and it is too much. So how many it is actually? So if you want to calculate that, then you can use the formula 2 raised to, you can do 2 raised to host bits. That means total number of host bits. How many total number of host bits you have? So you can calculate that host IPs per network. Now host IPs, that means we can use those IPs for machines, and machines means we can say it is host or node. So how many IPs we are having here is what? For that we have to calculate it. So we can say it is 2 raised to, now how many host bits we have? So we know that after first part is the network part, and that is what, 8 bits. So the remaining part is the host part. So what remaining part? These 3 parts, and these 3 parts means 8 bits, 8 bits, 8 bits 3 times, and you have what, 24 bits. So actually the total number of host bits we have is 24. So you will do 2 raised to 24. Now you know when you do 2 raised to 24, what you will get is this 2 raised to 24, and you will get this. It is like 1 is 1,000, 10,000, 100,000, and 1, then million, and then 10 million. That's 16 million 77,100,000, 7,000. Okay, 216. It's too much. So what you will get here, how many host IPs per network? Remember, I am saying per network, not total. So per network you are getting 16 777 216, and this is what you are getting, and this is only for one network. And like this you have 128 networks like this, where every network has these numbers of IPs. Now it is too much, and that is why I said the class A is for the big network organizations. Like they are having a big organization and they need lots of IPs. So for them they created this class A, so that they can, if they want, they can give them one network of class A, and in one network of class A they will get this number of IPs, and this number of IPs is too much, and that is why what you are having less networks. That means these kind of companies can be very few, so they are created only 128 networks like this. Now remember, these two IPs we can't use. This is total range. That means from this network IP to this broadcast IP. Now remember, I said like you can't use the network IP where all the host bits are 0. You can't use it. And if the host bits are 1 on, then again you can use it. It's a broadcast address. So basically you can use only the IP from this between IP. So this first IP and the last IP in one network you can't use. So if you want to see how many valid IPs we have, so for valid IPs you have to divide from the total IP, you have to deduct 1, and what you will get is this 214. So this is actually your valid IPs which you can use. The total is 167772116. But if you want to, not one, actually two IPs, one is network and one is broadcast. So this is what valid IP for your network, and this is what class A. Now if you say class B, so as class A ends on 127, the class B will start from there. Okay. Now class B. Class A ends on 127. So the class B will start from 128 and it will go to 191. Now here is no reserved network, no network for the default range, default route, no network for the loopback. It is only on class A. Now we can use these. This is the valid range that we can use, 128 to 191. Now here in class B, as we know, in class B, so this is what class A, where you have to leave the first 0 bit and you have remained the 7 bits to use and 24 bit for the host part. So that is why you get this number of host. Now this is not proper. I will change this again. Okay, I will fix it. Okay, so now class B, when you see the class B, so I said here this class A was for the big range, big network. The class B is for middle range, middle network. Now what they did here, they created two network parts and two host parts. Now they reduce the host parts, because remember in class A there was 3 host parts and you are getting lots of IPs. Now here you have only 2 host parts, and the range for class B will start from 128 to 191. So 128 to 191, and that means what, it will start from 128.0.0.0. Now remember, and that means what, this is what, again a network IP of class B. Now why? Because these two parts are network part and these two parts are host part, and you can see the host parts are 0. Now whenever any network IP, any IP, if you see the host bits are 0, that means what, it is considered as a, it will consider as a network address. It is network address, or we can say it is a network IP, and that means we cannot use it. And you can see it is what, network IP. So the valid IP which starts in class B is what? This one. And how it will go on? Same as class A, like it will go on like it will become 2, then it will, next IP will be 3, then 4, then 5, then it will reach up to 255. Then this 1 will change to, this 0 will change to 1, and this will again become 0. Then it will start again from 1, then 2, then 3, then 4, then 4, then 5, then 6, then one time it will become 255 again, and then the next will change to 2 and 0, and then the next IP will be 2.1, then 2.2, 2.3, 2.4, 2.5. Now one time come when this IP will be 255 and this will also be 255. Now what will be the next IP is this 1.0.0. Now here what happened, this will change. Now this will change means what? The network part will change, because the first two parts are network part, and if this part changes, that means your network IP change. So that means what? This is what? A network part, and if this part changes, that means network change. That means this is the last IP of the network, and the next network will start from here, and this will be the network IP of the next network, and this IP will be considered as a last IP, and that is what? Broadcast IP. Broadcast IP of this network. So valid IPs are from here till these all IPs will be considered in a class B valid IPs. So the last valid IP will be 255.254. So the class A IPs will start from here, then it will end it here. This will consider as a network IP. This will be the broadcast IP for this, and this one, these ones will be the valid IPs which we can use. So in any network, we have to leave these two IPs, network IP and broadcast IP. Network IP where all the bits are off, and broadcast IP where all the bits are on. Now here what happened? The IPs are getting less. We are reducing the host bits. That means we are reducing the host IP, but we are increasing the network. That means we are increasing the network. So in class B, you will get more networks, then more network and less host as compared to class A. So they assume like maybe middle-sized companies can be a very many companies who will need less IP than those big organizations. Now, how many IPs we are having here in class B? How many networks we are having in class B first? Total number of network. Now remember, it has increased the network bits. So how many have we have here? Now we remember that it is increasing the network bits. Now network bits are what? If we see the total network bits in class B is what? 2. 2 network bits. 2 parts of 8 bits, and that is what? 16 bits. So the total number of network bits are here is what? 16. Now the formula says you have to remove the reserved bit from the network bit. Now in class B we are having 2 reserved bits. Now what are those 2 reserved bits? Now in class B we are having actually 2 reserved bits from the first 8 bits, and that 2 reserved bits are that first bit will always be 0, 1, and the second bit always be 0. The rest of the bits can be any. So the rest of the bits can be any. So for the from the first 8 bits, the first bit and the second bit is reserved like this. Then the first bit cannot be 0 and second bit cannot be 1. Why it is like this? Because you see, if you disable the first bit and if you enable all the rest of the bit, then still you will go up to 127. You will never reach 128. That means if the first bit will get 0, then you will never go to class B. You will always remain in class A. So it is reserved that your first bit must be on. So this first bit, when this will be on, then your value will always be more than 128. Either 128, if suppose only first bit is on and all the rest of the bits are off, you will get 128 and you will start in class B. Now if you enable this bit with this bit, first bit, if you enable the second bit, then you will get the problem. Like if you enable this bit also, then what value you will get? You will combine these 128 and 64, and the total value you will get here is 192. Now 192 means what? It is out of class B. Whether you are not enabling any of this bit, but still you are getting out of class B. Why? Because your class B starts from 128 and ends on 191. But when you enable these two bits, then what you get? You get 192. 192 because 128 and 64 plus 192. So if you enable both the bits at the same time, you will get 192 and you will get out of class B. So you cannot enable this bit and you cannot disable this bit. So the reserve bits are 2. This one always be what? 1. This one will always be 1 and this one will always be 0. You can do anything with these bits, but you cannot change these bits. So these 2 bits are reserved here in class B. So from 16 I have to minus 2 to get the real value of class B networks. And what we get here, so total number of networks we are having in class B is 16, okay, 2 raised to 14, and we have 16,384. 16,384 networks. Total number of networks. That is total number of networks. Now in one network, how many host IP we get? So This is the formula, and what we get here is 2 raised to host bit. Now how many host bits we have in class B? So how many host bits we have in class B? So we have again host bits is also 288, and that is what 16, because it is divided into half, 2 network 2 host. So 16 network bits and 16 host bits, and what we get here is 2 raised to 16, and that means what we will get 16,000, not 16, we will get 65,536. You can use it in a calculator also. 2 raised to 16, and you will get 65,536. 65,536. But this is not a valid one, because for valid IPs you have to leave 2 IPs from here. So you have to divide those broadcast and network IP, and when you do that you will get 65,534, and that is what valid IP in class B. So as you see, in class B one network you will get only 65,536 IPs, and this is smaller than class A. Now the IPs, the host IPs is small, but the network is increased. In class A you have only 128 networks, but here you have 16,384 networks, so that they can give each network to every other organizations. But still 65,000 is still too much. There are some organizations, there are some companies, they don't have these much machines and these much devices, so they need less IPs. Now for them they created class C. So they created class C for them. Now class C will start, remember class B ends on 191, so class B will start from 192 and it will go up to 223. 223. Now 223, and in class C as you see this is class B. Now in class C they have increased the network. Now you have three parts as a network bit and only one part as a host bit. That means you are getting more networks and less host, and the range is what, from 192 to 223. Now that means what, your IP will start from 192.0.0.0. This will be your network IP. Now why? Because you can see instead these three is a network part, but this only one is a host part, and all the bits are 0, so it will be considered as a network part, network IP. Now valid IP will start from 1, and same it will change, same like this, like 0, then it will be 2, then next IP will be 3, 4, it will reach to 255, then the next will be this, and this will become again 0. Now wait, now actually this one is also a network. Now that means what, your network will end here. and this IP will be the last IP of your network, and this will be broadcast IP. So you are getting less IPs for host, and the next network will start from here. So you are getting less IP for your host. So your valid IPs will only from here to 254. So you are getting only this number of valid IP, and what you are getting more is what the networks. Now how many networks you are getting here in class B? So again you will see the formula. So 2 raised to network bit minus reserve bit. Now how many network bits we have in class B? A class C. So we can say that class C has 24 bits as a network bit, because you see all three parts of the IP are network, that is 888. So 3 8s are 24. So how many we have here? We are having 24. Now here also we have reserve bits for networks which we cannot count. Now what they are here is what? How many network bits are we have here in class C? So in class C we have first bit reserve as 1, second bit reserve as 1, and third bit is also reserved as 0. We cannot change these 3 bits. Now why we cannot change? Because remember, if you disable these 2 bits, any of these 2 bits, then you will never reach to 192, because you will only reach to 192 by enabling 128 and 64. If you leave these bits and if you enable all these bits, you will not reach to 192, never. So you cannot leave these any of these 2 bits off. You have to enable this bit, otherwise you will never reach to class C. You will always be in class A or B. Now the third bit, you cannot enable this also, because this bit value is what? 32. Now if you combine 128, 64 and 32 together, then you will get 224, and this means what? It will get out of your class C range, because your class C is ending on 223. So you cannot enable this third bit also. So your reserve bits are 110. These 3 bits are reserved. You can do anything with this rest of the bits and all the rest of the bits. So you cannot change this first 3 bits. So you have 3 reserve bits in class C. So you will minus 3 here, and when you do this, so you will remain what? You will remain 2 raised to 21, and that means if you raise 2 to 21, then you will get 20 million, 2 million, 2 raised to 21. You will get 2,097,152. So 2,097,152. 1152. So you will get this number of networks, and it is too many. So you're getting more networks than host. Now how many hosts you will get? So actually you will get how many hosts you will get in a single network. So you will count the host bits. Now remember, host bits are only 8 because you are having only one part as a host part, and that is 8. So you will get only host bit as a 8 bits. So when you raise 2 raised to 8, we have already calculated this. When you do this 2 raised to 8, so you will get what? 256. 256. And if you want to check the valid IP, that means you have to divide subtract 2 from it, and you will get 254, and that is what you get a valid IP. And you can check here easily that you are getting IP from 1 to 254 because we are leaving these two IPs, network and broadcast IP. So this is what class C. Now after class C we are having class D and class E. Now this class D and class E, class D and class E we can't use. These are not for commercial use. These are reserved for different thing. Now first, if you say class D, and you know class C ends on 223, so class D starts from 224 to 239. Now you see the class D is reserved for multicasting. That means in that class D, that RFCs state that the first 4 bits of the first byte must always be turned on or set to 1. So considering the following network address will be from 224 to 239. Now it is saying first 4 bits as this, like first 3 will be set to on, and the fourth one will always be 0. Now why it is that? Because you know first one is 128, then 64, and then 32. If you disable any of this bit, you will never reach to 224, and you cannot enable this one. If you enable this, then it will become 240. That means uh, 248 actually. This is 128, this is 64, 32 and 16, and it will become 248, and it will become more than this 240 actually. It will become more than this 239. So this one is reserved, but there is no network part and host part here because this IP we can't use it for normal machines. It is reserved for multicasting, and reserved for multicasting, that means if you try to assign these IPs to any machine, any device, it will not allow, it will not take that IP. These IPs are used for some services or some devices for doing the multicasting type of transfer. Multicasting, that means we have seen like multicasting is like one to many. That means one to many, not all, like one to some group of devices. Like there are some services which use this, there are some protocol which uses IPs from this to communicate with their own services devices and their own protocol devices. So these are reserved, we can't use it, these are fixed already. Then the last class is what? Class E. It remains, that is from 240 to 255. Now 255, that means it is end. we can't go more than 255 because we are having only 8 bits. And this class which used to research and development, it is used to research and development by the INA engineers, and we can say that all the 4 bits of the first 32 bits are reserved for 1, like you cannot disable any of this bit, but we can't use it. There is no dividing of network and host part. We can't use it because it is reserved for research and development by the INA. It is not for public use. And these are the 5 classes we have. In the summary you can see these are the classes, these are the leading bits, that means the reserved bits, these are the network IDs, and these are the host bits, network bits, host bits. These are the number of networks we will get in all these, and you can see in D and E it's not available. Then how many network host addresses we get, and this is the start address, this is the end address, you can see for every class. Now, like the first address 0.0.0 is reserved for the default route, the last IP, that 255.255.255, it is also a reserved kind of IP, and this is for the global broadcast. We can say if you broadcast your data in this IP, that means it will go to any IP of any network. It will go to the whole TCP IP, the IP version 4 IP addresses in all the classes. If you broadcast your data with this broadcast IP, these broadcast IPs are only for that network, but this one is for all the networks. The last one where you have 255.255.255. Now there is one more important thing. It is called subnet mask. Subnet mask is used to differentiate the network ID and the host ID from given IP address. That means when you write any IP address, you will not able to differentiate. You know that this is the structure, so if you memorize it, and you have to memorize it, then you will know that okay, if it is class A, that means it is having one network and 3 host parts, and if you are saying it is class B address, that means first 2 is a network part, and the rest of the 2 is the host part. And if the if the IP is class C, then you know that it is first having a network part, first 3, and the last one is the host part. So you know if you memorize it, but how it is going to be differentiate in machine? When you give a IP to a machine, then how the machine will differentiate it? And that will be differentiated by this subnet mask. So whenever you assign IP to any machine, any device, you have to give the subnet mask with it, and that will differentiate that which is the network ID and which is the host ID. And it is important if you do the subnetting also. That is the next thing which we do. So the subnet is the subdivision of a network address that can be used to present a part of a larger network. A subnet mask is 32-bit number. Now just like IP addresses, this subnet mask is also a 32-bit addresses. And 32-bit addresses that makes an IP address and divides the IP address into network address and host address. It is also a 32-bit address, and 32-bit means it is divided into 4 parts of 88 bits, just like IP address. Now the default subnet mask for the different classes are, now these are different classes, and these are the default subnet mask of those classes. Like for class A, the subnet mask is 255.0.0.0. Now you know that first part is a network part, so it is defined by this 255, and 0 means host part. In subnet mask, very easy. If you see 255, it is what network part, and if you see 0, it is the host part. But actually 255 means what? All the bits are on. That means 255 means what? All the bits are on. And 0 means all the bits are off. That means what? In subnet mask, actually when a bit is on, it will consider as a network. and when the bits are off, that will be considered as a host. So very simple. If in subnet mask it is also a 32-bit address, and when you see 1, if the bit is on, that means network, and if the bit is off, that means it is host. And you can see here in class A, first 8 bits are on and the rest of the bits are off. In class B, first 16 bits are on and the rest of the bits are off. In class C, first 24 bits are on and the rest of the 8 bits are off. So first part in class A, class B first 2 parts, and class C first 3 parts. Now D and E we are not using it, so we will not get into it, but if you want, then it is having all the bits on here. So this is what subnet mask, which is very important to define the network and host parts. And here is also saying what about the network addresses. As I said, if the host bits are on, it is broadcast, and if the host bits are off, that means it's a network address. So each network is uniquely identified by the network addresses, which is also called the network number, and every machine on the same network shares that network address as a part of its IP address. And in the IP address, like 127.172.1630.56, for example, this is what class? This is class B. So if it is class B, that means this first 2 is what? The network address, and the node address is assigned and uniquely identifies each machine on the network, and this part of the address must be unique because it identifies a particular machine, an individual, as opposed to the network, and which is a group. So this number can also be referred to as a host address. And in the sample IP address, as you can see, this the 30.56, that is this part, remember it is class B. And how I know? I know by seeing only this 172, because 172 is under 128 and 191, that means it is class C. So the first 2 parts are network and the rest of the 2 parts are host address. So this is the node address to ensure efficient routing, and class A network addresses always starts with a 0, and then route might be able to speed up packet on its way after reading only the first bit of its address. So this is where the address scheme define the difference between class A, B and a class C addresses. So class A, B and C are the only range that are used to address host in our network. Rest of the class like D and E we don't use. D is reserved for multicasting and E is reserved for the research and development purposes. Now one more thing is there, public and private addresses, and then we will go on to do the subnetting. Okay, now these things, public, private IP addresses and all that, and also subnetting, we will do it in next lecture.